Good morning, Year 10s. This is a new topic with Mrs. Newsom, looking at trends in the periodic table. This comes in as Unit 4 on your scheme of work. The syllabus asks you to understand how the periodic table is put together and why certain elements are in certain groups, and looking at the properties of each group and the trends in those groups. There are only 4 groups you need to know in detail, and that's what we're going to start with today. So today's group, we're going to look at group 1, the alkaline metals. Now what I've tried to do for you here is I've tried to use a bit of dual coding. If you're not familiar with this, what I'm going to try to do is give you pictures to represent the information I'm teaching, so hopefully it will stick in your memory a bit easier. Let's see how we go. Okay, so group 1 of the periodic table. So we're looking at this group here. I know it's group 1 because there is a 1 at the top of the column, and we're looking at the stand-up vertical column, not the lying down rows. Now on your periodic table, that number is in brackets, not the other number that we sometimes see. And this group is known as the alkali metals, and you need to know that name for that group. So group 1, the alkali metals. So you can see hopefully what I've tried to do here, I've turned the L of the alkali metals into a number 1, and it helps jog my memory. What is that group called? Number 1, oh, it's the alkali metals. So the first thing you need to understand about all of these elements, from Li, lithium, all the way down to Fr, francium, all of these are alkali metals. They're like a family. They're very similar to each other, but they're not identical. But the first thing you need to know is that they are metals. So this is the symbol I'm giving you for metal. Okay, group 1 are metals. Okay, so let's look at each of these metals in turn. So I'm going to look at lithium first. So you can see the top GIF there. Rather unusually for a metal, lithium can be cut very easily with a knife or with a pair of scissors. Now you can see also in the diagram it's still shiny like a metal. It's still going to conduct electricity, but unusually for a metal, it's very easy to cut. If you look at the second diagram, again, very unusually for a metal, that metal is floating on the water. So you would say that lithium is not dense or has a low density. So unlike iron, that's going to sink to the bottom, isn't it? Gold would sink to the bottom of the water, whereas this lithium here is just floating on the top. Again, if you stay looking at your bottom GIF, you can see almost straight away, as soon as that lithium is put in the water, it starts to react. I've got bubbles forming, I've got gas forming, it's whizzing around. This lithium is reactive, very reactive for a metal. Now, the last thing I've got here that you need to know that I can't show you on the slideshow is about the melting point. And you need to know that the melting point of lithium is low. You don't need to know the exact numbers, but it's a low melting point. Now, you could then take that a bit further, couldn't you, and say, well, what does that tell you about lithium? Well, you could talk about the strength of the bonds. If it's got a low melting point, it must have quite weak bonds, and therefore the amount of energy needed to take those bonds would be quite low. So low melting point, weaker bonds, not much energy needed to break them. Okay. So then let's look at the next one. Let's look at sodium. Okay, again, you can look at that top GIF there, and not only is it easy to cut, it's actually easier to cut than the lithium. So when I'm doing this as a practical, sometimes lithium is quite hard work to get the knife through, whereas sodium, you can see it's a bit like cutting cheese, really easy to cut through. Again, it's a bit harder to see on the bottom GIF, but it does float on water, and therefore it is low density. Now you can see, I mean, it's hard to even see the sodium in there, isn't it? It's instant reaction. You can see as soon as it touches the water, you get flames, you get a chemical reaction. So you would say not only is sodium extremely reactive, you could actually say it's more reactive than the lithium. And again, it's got a low melting point, and you could talk about the bonds. Okay, so potassium. Coming down again to the next one in the group. Now, I don't like this top GIF. It gives you the impression that potassium's harder to cut. I think it's just the GIF. Cutting potassium's really easy. It's really very, very soft. So it's getting even softer and even easier to cut as I come down this group. Again, you can see the potassium there. It does not go underneath the water on the bottom GIF. It sits on the top. It floats. It's got a low density. And if you look very carefully at that GIF, almost before it touches the water, the potassium is starting to react. So again, not only is potassium reactive, it's even more reactive than the two that came before. Finally, you can say it's got a low melting point, and you could talk about the bonds and the amount of energy needed. Okay, so this time I'm not going to help you out just yet. Could you predict the properties of rubidium? It's further down the group. So I've done lithium, sodium, potassium. I'm looking at rubidium. It's further down the group. What could you predict for me about the softness or how easy it is to cut rubidium? Well, you might think, well, so far as we've come down this group, the metals have got easier and easier to cut. And therefore you might say, well, okay, I'm going to predict that rubidium's easy to cut, but I could also predict it's even easier to cut than potassium. Can you see the trend? Getting easier to cut as we come down the group. What about the density? Now, you don't need to know about the trend in the density, but I would hope you would predict that just like the other three, rubidium is low density, not dense. What about its reactivity? Well, so far we've looked at three of them as we've come down that group, and I hope you agree. We could say as we come down that group, the elements, the metals are becoming more reactive. And so if I follow that pattern, that trend in the data, I would predict that not only is rubidium reactive, but it's even more reactive than the three above. So as I'm coming down that group, each one is becoming a little bit more reactive than the one before. I'm also going to predict it's got a low melting point. And I think that's about it, isn't it? Here's my diagram, or here's my GIF of rubidium, and you can see why they don't let me play around with it in the lab. Most unfair, if you ask me. I'm pretty sure we wouldn't hurt many people, maybe the front row. Okay, let's have another look. So this time I would like you to pause the video, and I want you to think about the images you've seen time and time again in the last few slides. What could you predict about the properties of cesium? So pause the video and I'll come back in a second. Okay, so if you pause the video and you had a go, well done. Let's have a look. So hopefully you are predicting that cesium is not only easy to cut, but it's easier to cut than the others, than rubidium in particular. Hopefully you've predicted that cesium is low density or not dense because the others were not dense. I'm hoping that you would have predicted that not only is cesium reactive, but it's even more reactive than rubidium. And hopefully you've also predicted it would have a low melting point. Now, you could easily be asked a question in the exam, why is Mrs. Newsome not allowed to use cesium in the lab? And you might say, well, it's more reactive than the others. It's going to get pretty dangerous. I would argue that's pretty spectacular, but you can see why they don't let me do it. Okay. Finally then, francium. Now, I'm not going to bore you to death. I just want you to see yet again the same four properties: low melting point, easy to cut, low density, and obviously reactive. And you'll notice francium then is the most reactive element, being at the bottom, and the easiest to cut. Now the GIF on the left-hand side is not francium. If you Google francium in water, this is what you get. I think it's a little bit of make-believe, really. Francium is extremely rare, and there's no way they'd be blowing it up like that. So this is the easy bit, guys. This is the properties, and you need to be aware that the group 1 metals then have these 4 properties. They're all going to have these properties, and then 2 of the trends: getting easier to cut as you come down and getting more reactive as you come down.